Okay, should be live. So it's been a while. And actually, I was just thinking of doing a bit of some speaker stuff this evening, but some other stuff came up on IRC, and I just remembered that we need to add a toggle so that emulators on Asahi Linux can use the TSO feature that Apple added to the M1 and the M2, which basically turns the ARM memory model into the x86 memory model, which is like a subtle thing that most apps don't care about, but some of them do, and emulating it is a giant pain in the ass. So it's 1 bit basically that we just need to make useful, but it makes a big difference for emulation. And so we need that to have like production ready fix support on Asahi. Right now, there's a patch that I think Lena wrote on the on Mini to enable it system wide. It's just a hack. But we need to expose it with a process control. So I'm going to look at that, and I'm also going to see if I can get myself some music first, because I just realized I don't have Spotify running. So I do want some background music. Let's see, what do I want to play? Just for myself. And a second. Yeah, that'll work. Okay. So let me get the kernel stuff, and I'll switch the screen around. I have a decent Kate profile, I'm not sure. Oh yes, that's the speaker safety stuff. Oh, this will work. And a bunch of things missing. Okay. Okay, let's go with that. So, we need to add the prctl, which is basically, so we need to hook up, not pctl, prctl. We need to hook up a system call to a CPU register. That's the entire thing. That's literally, there's 1 bit. That's all we need to do, but it's easier said than done, because I need to do this in a way that has some chance of getting upstreamed. So first we need to add the actual prctl for it. And that's already going to be controversial. So I just noticed this is one that came from Android, and they switched, instead of using like incrementing numbers, they switched to like a 4cc. I don't know if this is the right way to do it, but until it gets upstreamed, it's going to be, I don't know if this was reluctantly accepted or if it's the new accepted way of doing it. But if I add another number, it might not end up being the right number in the future. And if I add one of these, worst case, we break compat, but we don't step up anyone else's toes. So I'm just going to do the same thing that this Android prctl did for now. So that one I think is VMA or something. And we're just going to call this something like set memory model. It's like MMDL or something like that. And then we want to get, oh yeah, we need a set and a get, I guess. So I guess just make the top one lowercase or something. Forget. Just to be 60. Yeah, 60. And this is just, I'm just kind of making up the interface here, but we can shape that yak later when it gets upstreamed. So it's going to default. And a TSO. Yeah, I think that'll be fine for now, and this will definitely. So I'm sure we're gonna bike shed this interface forever once it gets upstream, but for now this will be okay. So the next part is how on earth do I hook this up into the CPU? So there is where's the prctl stuff for Arch 64? Arch set mem model. Wait, is that already a thing? No, okay. You mean that's what it should be called? That's how you do it? Yeah. Wait. So where is it hooked up to the actual, where's the actual prctl list, though? Like, where's the entry point? So I'm trying to figure out. It's here, right? So it has to go in here first. Yeah, I saw the SV stuff, yeah. And so that should be in here. Yeah, so this is the entry point. The entry point has to go in here. And apparently that's macro. Oh, but there's some other stuff. Arch prctl spec. Yeah, okay. So we'll the speculation control. That's a good example. Yeah. And apparently you just get arguments like that. arg2 should be set. Wait, how? Why does set take 2 arguments? Oh, okay, because this one uses it's indirect. So in this case, we would have get mem model and set mem model, and everything else has to be 0. And for set, everything other than that has to be 0. Mem model get me mem model set me arg2. Oh, and you can just have weak ones here, yeah. So that also makes sense to do the same thing. So we can do the same thing here. So that should already compile, and I am going to compile it because I get the feeling that header file change is going to make the entire world recompile. Yep. So while that runs, let's see how this happens in Arch. So we have prctls. Yes, we have some stuff in Proton Pack. So I don't know where we would put this. Maybe in process. And this is just like, yeah, so we need to look at how this is done to save restore registers. And this is probably a good place to start. The memory tagging stuff is just going to be global the same way. Yeah, so we get, there is a thread state, and we're going to have to add some thread state. So this is where it gets interesting. This is where they're going to start thinking, no, like thread state. Okay. But it's basically just this. And the good thing is that the register we need to save and restore is actually a standard register with non-standard meanings. Let's see if I can add a config for that. So those are the platforms. In kconfig, stuff arch. Should probably just be in here. Yeah, so there's SME there. Somewhere here. Yeah, so it looks like that one is outside any menu, and that's probably what we want. So just put it in here. And yeah, ARM64 Apple TSO. Or even just TSO. Yeah, and then it'll be like a CPU feature of some kind. Yeah, so let's call it ARM64 TSO in... you know, sort of as a generic thing, so that if other... Because also, this should enable... okay, so let me say a thing. There is at least one or two other ARM64 CPUs that already do TSO by default, and those should report... you know, TSO mode by default, right, on the prctl. So we need to define the API for setting TSO mode, But I think what the API is going to be is that by default, you get the default, which is whatever is the case for, no promises. And then you can set TSO mode. And if the syscall succeeds, then you're guaranteed to have at least what you asked for, even if it returns default anyway, because you're already in TSO mode. If the syscall fails, then right. So if it succeeds and then you get it again and it says default, it means the default is TSO. If it fails, then there's no TSO. So it should succeed on CPUs that are known to be inherently TSO, which means this is not technically Apple specific. Switching is Apple specific, but it will do the right thing on machines that are TSO anyway. We just need to say which ones those are. So we're going to call it something else then. And then I'm going to want another thing. I'm going to add a separate ACTLR state so that we add ACTLR to the thread state. It's not system, process memory, a CPU memory model. And then we're just going to call it the you familiar with the Open Core Legacy patches? Sorry, I have no idea what that is. This feature. Okay. So then in processor.h, I'm going to do that. And I think that's going to be another full rebuild because of course it is. So we turn that on. Yeah. Okay. So the next thing is how do we detect this at runtime? So I know Apple has their own they have their own feature flags, right? And so this for Apple CPUs that implies adding support for their proprietary, CPU ID flags and stuff. And I don't know how to do that. There's CPU features stuff in here. Let's see. So the CPU feature, and this is going to be yet another full rebuild, isn't it? Yeah. Yeah, so we can define a new register like that for the Apple stuff. I think is Apple have their own feature register, so it makes sense to use it. Source XNU. So the enable TSO flag is that one, and then I know they have, yeah, that one. Wait. Did they stick the Apple memory feature in the regular feature register? I thought they had their own feature register for this. Oh yeah, AIDR. I think it's an AIDR. I think. But it might not be. So I think AIDR is also a standard register. Yeah, so it should be in there. It's just I don't know what the bits are for that. I don't think we have those. Yeah, it's in the. Oh, they even have a second ID register. Oh, that's lovely. And that one's custom. Okay, let's see what those registers actually have in them. Okay, so there's a lot of stuff there. It'd be really nice if we knew the bit definitions, because I'm sure it's in there. But of course we don't. Let's see. Do they check for anything here? No, it's not. It's not anywhere. Do I want to... Do you want to start disassembling the kernel? Yeah, I'm kind of tired of guessing around this stuff. Okay, so I was looking at this stuff earlier because I was looking at some of the hypervisor stuff that Apple had, and I was looking for the weird interrupt controls that I fixed an issue with VMs on Asahi the other day, and I actually loaded a recent full kernel into Ghidra because they are they don't even publish the hypervisor binaries in the KDKs. It's just like if you compile your own macOS kernel, you don't get hypervisor support. But actually, I don't know if the TSO stuff is in the KDKs. Some kernel support. No, TSO. That doesn't look right. No. It's probably another thing they only have in the real kernels. So, you know what? I'm going to open up. You're not going to see much here, but yeah, there's the kernel I was looking at. You're not going to see much because the text is tiny in Ghidra, but I'm just going to see if there's any mention of TSO and if they check any AIDR bits, because that would be nice to know. So if this is the TSO, and of course that's also TCP segmentation offload, which isn't going to help. No, that's also segmentation. Nope. Okay. I mean, you can check ACTLR. Let's see if there's any functions called that. No, that's all the network stuff. Socket stuff, kernel stuff. There's too much noise from the TCP thing. And I don't know if they call it TSO or if they call it something else. Because there was a TSO enabler, right? That I think just called like the system call. Oh no, it is its kernel extension. Okay. So what is that doing exactly? Okay, they're just poking the ACTLR. Okay. So there's probably search for ACTLR. Yeah. AIDR. You can get it. But yeah, it just reads it. It's not useful. Yeah, ACTLR 1.2 is just reading from that, and AIDR. AIDR is actually, yeah, it's just reading from the register. But it doesn't say what the bits mean, unfortunately. Be really convenient to get the TSO stuff there. And I'm guessing TSO, well, I want to see if anything, yeah, but it's going to be in the thread function. Hmm. CPU feature bits, that sounds useful. CPU features. Oh, that's a function, okay. Search for feature. CPU feature, bit CPU features. Something here could be useful. I wonder if any of that is documented anywhere in user space somehow. Bits. 'Cause that's probably generic. Ah. Yeah, the CPU features. But then it's only 9386. Okay. CPU feature names, CPU features. I mean, that sounds useful. Is there a table for this? Ah, yes. Okay. And that's a pretty long string. Okay, is anything interesting here? This looks like x86 stuff. Why is this in the ARM kernel? That doesn't make any sense. So why is this returning virtual apple? I guess that's when there's nothing known, because this is the standard kernel. This is not a virtual kernel. Yeah. Just in case anyone has documented any of that. Doesn't look like it. Something is checking for AIDREL1 there. Yeah, sorry. Ghidra doesn't scale properly, so the font is tiny. Sorry, I can't do anything about that. That's our own page there. ML feature supported. Okay. Yeah, it's in there. And nothing calls it. Do any extensions call it? Yeah, the call's there. Nothing calls it, though. I think nothing might use that, yeah. Let's look in kernel support in case anything there and core services, but I don't think so. Yeah, just machine routine stuff, but that would just export it. It wouldn't. Wait. But why only 8101 and. Oh, I guess they only have those two. Okay, yeah. They use that for all of them. Okay, that's fine. Yeah. Yeah, no, as I said, Ghidra has tiny fonts. I can't do anything about that. Uh, yeah, it doesn't look like we have any hints as to what the bit is for that. Now, there definitely is a bit, and probably some version of XNU had some mention of that somewhere. I can search for any other hits for AIDR. Search for, let's see, search program text, instruction, mnemonics and operands, search all. Right, so that's the mild DSP one. We know that feature bit. And there's a syscontrol to just get that. I mean, I'm guessing Rosetta has to use this to figure out if it's supported or not. Oh, there's some there. Oh, hey, we had this in our wiki. Where did I get that? And of course, this is a wiki mirror. Because I remember seeing this somewhere. Yeah, so we actually have it. It's bit 9. But now I don't know where this came from, because only these first 3. Yeah, I don't know where I got that from. Or if someone else got it from somewhere. But apparently it's bit 9. Is there any other hits for that? No, it doesn't look like it. Yeah, now I have no idea where that came from. Clearly came from somewhere. Because the only bits are that I have here are these 3, right? Mo53, WKDM, and Arch Retention. Anyway, here are all the... Oh, is Rosetta supported? Well, that's convenient. This is doing... Okay, so now we know what Rosetta's checking for. That's convenient. Okay, hold on. Is there anything else? Yeah, there's a few things checking for stuff here. Okay, so mild DSB we know about. This is... Oh, AMX, okay. Oh, yeah. Okay, they were added by someone else. So this probably came from some other... Interesting. So then there's this CPU capabilities thing that gets put into the shared page. Oh, okay. And this is loading like all the features. Com page. Okay, the com page, yeah. So this is loading all the features into the com page. Okay. Is there anything in the about the comp page? Are there any defines that are interesting in here? This is ARM32. The function is called comp page populate. Do we have that? Yeah, we have some. We have the, okay, so this is generic ARM. What's in the actual code for this one? Okay, so all the same stuff is here. Okay, so there's that. And okay, there's the capabilities. And they stripped away. Okay, so is any of this other stuff public? ARM64 CPU capabilities, and let's look at both that old version and the most recent one in case there's stuff they recensored. Where'd the other one go? Okay, they definitely added stuff in here. I like that it's, 1, 2, where's the 4, 8, right? Like clearly there is a 4, 8 there, and they took them out. Let's gonna see if there's any other versions with more stuff in here. Nothing there. But yeah, there's obviously like a has AMX or something here. Either way, so for example, AIDR, let's look at the bit mappings here, right? So we have this code. I'm going to copy and paste it so you can see what I'm doing. So I read AIDR, those we don't care about. And so we're taking this, shifted 11, and that. So this is going to be that bit AIDR. And then we have 200 shift left 1E. Which is almost 32 minus 2. So that bit is that one. And then that 11 and that is it's 11 bits, so 3 and then 1 more. And then this one is F. And 16 bits minus 1, so there. Okay, yeah, so these are 4 consecutive flags that are secret Apple stuff. And they probably fit very nicely into this list. Yep, it's right there, isn't it? Yep, it's a hole. So these are secret flags. The bits here are... And in the order we have them... Actually, the other order, but... Nine, 23, 26, and 31. Okay, interesting. So it'd be nice to know what those are. 9, 23, 26, and 31. But yeah, almost nothing uses that. Okay, so let's look at the... Is Rosetta supported is asking for that. Yeah, so it's looking for all of those bits and all of those bits and whatever that is. Oh, that's a different thing. What's UVAR1? Oh, that's one of the memory things. Okay. That's probably checking for page support or something like that. .4K page support, I'm guessing. And then, so it's looking for this one, 800, and then a bunch of bits we don't know about. But this one is included in the list. .23, 26, and 31. Yeah, we don't know any of those. Well, we can just go with TSO for now, assuming that one is correct. At least if we have it. No particular reason to think that's wrong. Not here. Where am I? Yes, we have that. That'd be pretty nice to know what those are. Just guessing the name in case Google knows. No. K has... It sounds like K has feet. TSO. Or like Apple TSO. No. There's probably some user space that does print the CPU features anyway. If there's anything that prints that. Oh, there's some tests. Okay. Yeah, that extension is just twiddling the ACTLR register bits, so that's not terribly useful. I just want to see. Yes, Google, thank you. Some of these might be useful. So we're looking for ones between FCMA and flag M. So those are not there. And those are those registers. And it's just OpenBSD printing its own stuff. Yeah, I don't think, yeah. No. No hits for that. So yep, no idea where those came from. Probably some user space checking the bits, because I don't see it in the kernel. Though it might come from somewhere else, but either way, Rosetta asking for that feature is probably a good sign that that's TSO. So we'll go with that. And actually, what is that? Oh yeah, it's checking either AIDR or the what's the official feature here? Because that might tell us something about the page about the what those are supposed to mean. So this is checking that register. And the bit it's looking for is 16 bits running at 44. No, AFP. Yeah, so that's the okay, I get it. So that's the official implementation. This is the unofficial ARM implementation of the floating point Apple flags thing, which means this one here is the AFP Apple version. And I'm assuming this is TSO. And then we others we don't know. I am implementing TSO support in the kernel so Fex can use it properly. And I just spent a bunch of time reactivating where this bit is. Okay, so I'm gonna assume the bit is right in the wiki. So then we need to put something in here. Okay, where do we put these? I guess it has to be in here. Actually, oh right. So the errata is like a separate thing, and I think CPU errata, and it uses the same format, right? No, actually, it's capabilities, and this one's it's the same. Yeah, so we probably want to add another thing. People are gonna shave this forever, but ARM64 kernel. Let's have an impdef file for that, and we are going to declare the special features in here. And we can just have an Apple features there. And this is terminated by an empty. And we're going to have to declare capability. Which means it's going to be another recompile of everything. How do they maintain this list? It starts at 0, but then it has the workarounds afterwards. Do they just renumber everything every time, or? Also, I don't get the tapping here, but I don't know if they do. Oh, generated files, sorry. That's why it's like that. Where is that generated from, though? Oh, okay, here it is. Aha. Okay. So type CPU abstract boot CPU feature. Yep. And I don't need a special. Okay, so I need both. Well, I guess I can just check for an Apple CPU and then add these, and not worry about the CPU match. So okay, so what's the bit thing? I need the. Where's the bit stuff? I keep forgetting what that's called. It's bit ops or bit field. And those are static bool. I guess I'll just put it in here. And then this needs to go into the make file. Okay, that is in there. Field width 1, unsigned, min field value 1. That should do what I want. Where is the part that actually enables that? Here. Init CPU hardware caps, indirect list. And if the boot CPU is Apple, we can just check that and only enable it if that's the vendor. I think we had that kind of checked somewhere already. Probably in errata. So the CPU types. Yeah, there's the Apple one. We do check that somewhere. And I think that's fine to do. Actually, I should just redeclare this and do the check it in the actual feature, because I think that makes more sense. So instead of doing this, has impdef feature, and then we do the same thing the errata thing does for the checks. Yeah, so we check for that, and then we check for the sysreg. What about the implementer? Can't I just... Oh, so we have it like that. Yeah, but I want the vendor on that. I want a range of I want like everything Apple, basically. Yeah, it's a bit... Okay, just call it has Apple feature and drop the MIDR stuff. And then I can just check for Apple. Okay, so let's see how much I broke everything now. Then I need a feature matches, which is another thing that is not exported. And of course, we're compiling the world again, because of course we are. Okay, so now that we have the feature there, and then it wouldn't be local CPU for the scope, I think. Just drop that for now. Okay, so now that we have the TSO memory model stuff, so then the next thing I need to figure out is how to enable the actual process save restore here. And we can actually just add that in. We can actually do that. And then okay, I'm just going to put the prototype at the top here for now. And actually get it detected at least. Do I want a separate feature for ACTLR Safe Restore in general? Because I think we can use that for for alternatives. Do we want that? Let's see how they do it for other stuff. In process. Let's look at that one. So so this is system supports DPIDR2 thing. Uh-huh. Yeah, we probably want to add that to the H, which means another full recompile. Yeah, it's in CPU caps. Let's call it has ACTLR state. Okay, so then we will return that based on is enabled ACTLR state, and the cap would be has ACTLR state. Okay, so an example there. We have this copy thread stuff. Preserve current state. So this is all specifically TLS stuff. Where do we want to put this thread switch stuff? It seems to be broken out into different classes of things. I guess we just call it ACTR thread switch or something. EL1, not EL0. We had some Apple register things here, I think, already. Yeah, these. So we need to put some defines in here. That shouldn't be too hard. Why is that lowercase? That's a typo in the other file. Okay. And in this case, they aren't impdef registers. They're just impdef bits. So you can put that in here. Apple CPU feature. ADR Apple TSO. Bit one. And we probably want that. There's a separate cap there. I want to put this at the end and call it like TSO Apple, TSO. Yeah, maybe like that. TSO Apple. That's going to be another recompile. TSO fixed. Oh, and the field pause there, I need to fix that. That would be Apple CPU feature. Rename that. So that's the Apple one. And then the... What other ARM CPUs are TSO? So I know there's some, yeah, A64FX has TSO. And I think some of the NVIDIA stuff did. Okay, so there's more than that, yeah. Denver and Carmel. A64FX. Yeah. Yeah, I need like several things like that. Oh, okay. There's you can do it like that with a list like that. So we know that Denver and Carmel have that, and A64FX. Which is that one. I think ThunderX2 might also have that. Maybe not, though. Maybe not. Yeah, maybe not. Okay, so we'll call those there. And then we don't need any of that. Okay, now they're compiled. And maybe just call this one impdef since we have more than just Apple in there right now. Okay, has ACTLR state undeclared. Didn't I save that here? Yeah. Why isn't CPU caps? Oh, ARM64 needs oh, it's called ACTLR, not ACTLR-EL1. And then I'm going to need more. It's okay, so I need to enable the feature there. How do I do that? It's like a chained feature, right? So I can probably just not have a feature for that. And just chain it off of the TSO memory model stuff. Yeah, and probably just drop that. And then I can recompile again. And here in processor. No, wait, where am I? Should probably be called system feature for this one. And so the rest of the thread switch stuff. I think it's called in flush thread. What is flush thread? This copy thread, we're going to need that also. System has yes. Why did they call that has CPU has instead of system has? Oh, it should be called system has. Yeah, it should be called like that. Yeah. Probably make that always inline. I'm not sure if we need a flush thread or not. Okay, who calls flush thread? It's an exec. Okay, yeah, so it should be an exec, because when we exec another process, obviously, we should not be keeping the TSO state. Because that doesn't make any sense. So we do want that. So an fpsimd, that is... Yeah, that's for an XX, so it makes sense. And this is always messing with the... Is it messing with the actual registers, or is it just messing with... Maybe you should do both. I think it's fine to do the registers, because then the thread switch is going to switch that. So then we can just check for the Apple thing. Yeah, so we should probably just mutate the saved state and then rewrite it. I think that would make sense. Oh wait, but on flush thread, we don't even get the current thread. But I think that's just using current or something. Yeah, current thread info. Mm-mm-mm. Is that right? Is it thread info? It's thread struct. Okay, so thread info. Oh, there's this. Okay, that one has different things. Wait, shouldn't that just be new exec in here instead of the thread flush? I think that makes more sense. And then I probably should just use the art prctl thing there. So then we can actually just check the define for the memory model control. Actually, I can use the if enabled thing there. Probably makes more sense. That was, did you do that? Is enabled. And then we don't have to worry about resetting because that will do that. Arch prctl. And then the prctl stuff was here. Mem model set, mem model get. And that is mem model, so mem model default. Like that. Then I need to actually implement those, but that's fine. Elf check arch. So do I need something in flush thread after that? Might not. Who calls setup neo exec? Bin format stuff? Okay, I don't know if that's the best place to put it, but I think it makes some sense there. So then we can drop this one. So what about this other stuff? So we stay at arch dub task struct. Just copies the whole thing, that's fine. And I think we need preserve current state somewhere. No, we have ACTR thread switch already, don't we? Yeah, okay, so we need both. And so hopefully this keeps ACTLR with the default value except for the mutations we're going to introduce. Okay. And that might actually work. So then we just need the prctl stuff. Just basically going to be those prototypes. Just put it at the end, I guess. If defined, and then we can check the features there. Yeah, so we'll probably shave the yak of how to expose the it's always TSO case. But basically, if you have TSO Apple, then we look for ACTLR. And then on set, no, it's not what I do it. If we have TSO fixed, and it's TSO, return 0. If we have TSO Apple, I don't know if I need to save restore this stuff here now. How does that work for the others? This is complicated. Hold on. Can I get some SV thing? Pointer auth. Yeah, that makes sense. Okay, so that changes both the thread structure Yeah, okay, so we need both. And then we write it. Otherwise, if it's default, it returns 0. Otherwise, E and val. Okay, I think that makes some sense. That might work. Okay. Now let's see what's failing to compile, because I know there was something there. Process CPU has, it wasn't CPU, system has. Then model set. And those should not be weak. And I probably should just move them up before the other stuff so they actually work. Let's just put them in here. And then I'm going to need the includes. I can just hear the upstream argument about implementing this Apple-specific stuff in ARM64. Though I hope this feature is eventually official, because then it will be easier to say, well, ARM has Apple has an unofficial version for some. Okay, what is that read scoped sysreg thing doing? That's another. Bleh. Okay. What is that read sanitized feature reg anyway? Let's just warn if the scope is not system. Okay, where is that declared? There. Oh, okay, that's like reading a very specific thing for the overrides. So then I'd have to add AIDR to this. I think I just want to read sysreg on this. Okay, so Apple TSO is called TSO Apple now. And then I have an val somewhere. Yeah, there. And then that one, indirect list from array. I need that prototype in here. Okay. So really fix this and they have a way to omit barriers? Yes. No, there is a TSO config option in Fix. It's just global. So it just turns off TSO emulation. And if you turn that off with the mini system-wide thing, then that works. But this will allow Fix only to be doing that. Oh, field pauses. Oh, I see. Okay, I need not bit. I need the actual bit number there. Ah, okay. I should call it shift like that. Okay. Almost assembler. Oh, wait, what is it? How do I get entry in there? Also, that I guess isn't gonna work. I might have to use the other thing, yeah. I think we just skip the sysreg thing there. Actually, just a DREL1. The Linux version of Rosetta assumes TSO is enabled because Apple enables TSO for the entire Linux VM if Rosetta is enabled. Which is the same thing that happens if you enable TSO in Mini with Linux right now, which is how Lena was running effects with TSO. But it's system-wide, which isn't great. Okay, that compiles. Okay, so if I probably just want to run guest kernel and check the values from the hypervisor to make sure that makes sense. Yeah, that should be fine. Oh. Huh. Okay, there's more broken there. I renamed a bunch of system registers recently, and I didn't fix them all. Config. Oh, that's not going to work now. Okay. Did we get some nice stuff? I booted, it didn't crash. That's a good start. TSO memory model, Apple. Okay. Pick that up. That's a good start. Okay, so now I need to write a test for this. I guess it's just SSHFS mount it. So first, yeah, so that one is not set. That would be E00 if it were... No, wait, it's bit 1, sorry. C02. If that were set on that CPU and do it on the other, same thing. So now TSO test... prctl. And I need the prctl for that. Turn 0. And then I can just do while 1 here and... oh. Okay, that worked. And it's still C00, but I don't know which CPU this is running on. Because we're on CPU 0 now. Probably not that one. No, they're all C00. Not quite working then. Okay. Let's add some print to that. Let's do the get and see if it's getting stored properly at least. Okay, claims it's set. But it's... Oh! Aha, yes, it works. Joy said it right when I thought about it. Yes, okay, it's working. Look, 3 and 5 have... Well, actually, that's not necessarily right. Also, why does 0 have a funny thing? Oh, okay, that's... Isn't that a bug? I should be initializing that for the guest. That sounds like a bug in the hypervisor. What's bit 12? Do we know what that is? ICIV enable ACID. Why is that set for the guest and not for... But that's a bug for starters. We should be setting that for all the guest CPUs to at least the host value. And then where'd that 1 come from? Yeah, well. We do set AC... Oh, did I mess up this in it here? Or is it just Linux clearing it for some reason? I do initialize it to the same value as the host. Oh, I do enable... okay, yeah, so I do enable NM and DSB... Which is which bit? 12, okay, so that's intended. And it looks like it's sticking when the task goes away. So it's not quite working as intended. Yeah. But also, why is it like that? On the when we do the start, we load it, so it should be getting saved. So how did we end up with only 0? Is it because the task struct gets initialized to 0 in some context instead of getting copied? Okay, so what I'm going to do is see if I can catch Linux before it does any ESMP stuff. Oh, no, that's not what I wanted to do. Too early. Yeah, maybe the init, maybe there's like a separate idle task for each CPU, and that gets created without inheriting anything. Okay, so those are active. Okay, now we have... Yes, okay, so the hypervisor sets them all right. And then Linux is what is messing them up. Yeah, see, now we have one of them. Which is running nothing. It might have not loaded the symbols, I don't know. Maybe I broke the backtraces. Yeah. And they all became 0 now. Okay, yeah, my init is clearly not doing what I want. It means total store ordering, which is a memory model. Oh, there is a... Hold on. ptrace has that also. But we don't need that. Where does this get initialized? Init thread and ISM processor. Yeah, that could be it. Yeah, that could be it. Yeah. That sounds like it could be it. Okay, there's a setup here. Yeah, we probably might do it here. But you know what the tricky thing is? The tricky thing is that we don't actually. Okay, no, we do. What we want to do is we can load it here, and then only. Yeah, we definitely don't want to do this unconditionally on any other CPUs because they could have different ACTLR layouts for different cores, which would break everything. So the important part is that process here. As long as we have the guards here for everything. Might want to do a check there because that definitely needs to have ACTLR state if that's going to work. And then we just initialize it here. Not thread info, was it? It's thread. Okay, let's try with that. No, the ARM memory model is very well specified. It's very, very well specified with lots of test cases and examples and everything. It's just weaker than x86. Yeah, ARM has barriers, but I mean, that would slow everything down too much, yeah, because you wouldn't want to do that for every single load and store. Now it's really going wrong. That warning. I mean, we have that. How did we end up? How is that possible? Oh, wait. Okay, well, that also explains some things. I think we weren't even saving and restoring the ACTLR stuff properly. Unfortunately, I think that's another full recompile. Yeah, no, there was I think there was an update since then. There was a full formal model of the ARM64 memory model, probably published after that, so that's why. Yeah, full recompile. Okay, but I think we're actually doing pretty good, so let's do some git commits here. So here we're going to do false. Okay. Okay, so that's one, and that wouldn't be ARM, but we want like where is this? Is Okay, something like that. Okay, something like that. And then we add the memory model control. Well, I'll just add everything here. I think some of those weren't needed. I think I only need from array thing and feature matches, but not has CPU ID feature, I think. Yeah. Actually, no, we're going to do it in 2 steps. We're going to do this without default prctl. Do it without that. Probably want to do that. And then I need the impdef one, but not all of it. But I can't do add patch for the, yeah. Probably just do it like that, delete that, and then... Oh, and don't need that one either. And that. And don't need to print anything there. And then bit field has to go in CPU feature, not there, okay. And another thing is that I need to make sure that might break on hybrid feature, like platforms with more than one CPU type. So I need to figure out how to do that, like for features that are only used for one CPU. I think it's fine. Because I think I have the scope set to like system feature. Okay, so the one we want. Okay, let's read this. Okay, yeah, scope system makes sense. I think that's correct. Okay, so we need system and permitted for late CPU in this case. Yeah, so system feature is correct. So that's good. That makes sense. So I shouldn't break anything there if I do it like this. prctl, what's it called? That process. Oh, and I need to like undo that, yeah. So that, and drop the bit field. Don't need that, and don't need that. And don't need the PR format. And don't need that. Don't need that. Don't need that. Don't need that. Drop that. Drop that. And now it's gonna be a full rebuild. Because Git, but I think the previous build. Actually, no, it's not. Apparently. Good. Oh, hold on. That's an amend. Okay. Okay. Now let's see if it does what I want it to do. You know, I actually caused the change in the ARM64 memory model specification because I found that Linux was relying on something that wasn't in the spec, and I proved it with like, formal proof tests, and the answer from the ARM guys was like, yeah, that should probably just be in the spec, and they just retroactively added it to the spec, which meant Linux was not buggy. Okay. Okay, now we have the boot value, yes. Except in CPU 0? Okay, that's funny. Huh. Okay. Well, anyway. Okay, now we have one CPU with that. If I kill it, goes away. Okay, I think it's working properly now. Yep, and it's a different one now. It's 4. Yeah, okay. I think, except for the CPU 0 one, it's working properly now. So what happened there? Or is this... No. Okay. Huh. Well, it almost works. That's... Okay. Uh... Okay, so hold on. If I do... If I put it on CPU 0... Wait, now it... Okay, so it's some task that has the wrong value, but it's not... Yeah, it's like the idle task for CPU 0 ended up with that cleared, but not any of the other tasks. So what is running on that CPU when... Unfortunately, the backtrace is broken, apparently. I'll have to fix that sometime. What are the idle tasks called? Process 0. Where does the default idle task get initialized? init idle. And who calls that besides fork? Fork idle. So that's for creating the extra idle tasks. Shed init. Okay, so that calls well. It gets called well after setup arch. But I think there's going to be a thing before that that at least creates the current task, and that's what's doing that. Or maybe not. I think what's probably happening is that we're switching tasks before the ACTLR machinery is enabled, so the current thing doesn't get saved. So we need to save it explicitly there in the start. But I want to know where current gets initialized. Well, there's the init task there. So that is already created there before anything else. And how is that initialized? It is init task. Sorry, wait. So let's just do a print here. Okay, let's just do a print there to see if I'm on the right track or not, because it's possible that something else is wrong. Oh, and now CPU 2 also got the wrong value. Maybe there's something that causes that to go away. Where'd that print? Not sure that printed anywhere. Might need early con for that. Okay, 1 second, go to the toilet. I think I know what the problem is. And it's not that. The problem is the late CPU feature in it is gating some stuff that it shouldn't be gating. Like this one. No, but this one doesn't unset the whole task. Okay, who calls copy thread? That's some fork. Okay, so this calls dupe task struct, which is fine. So we shouldn't need that. As long as the duping does the right thing. Arch dupe task struct. Did we mess that up? No, they're just copies, so that's fair. So that should be fine. Why is the print not showing up? Because I'm... Yeah. Okay, that would do it. Okay, I think this is going to work now. So it looks like the net task is only... Yeah. Okay. Now it's going to be fine. Yep, that looks good now. Yep, there's the one running TSO, and then kill it. Goes back. Okay, I think it's done. Let's put these into a branch. Probably make a new one for this. Let's go to 220. It's a fun. It's the 200 plus is the fun stuff area. And I can just drop all that. Yep, looks about right. Okay, I said I might do some speaker stuff if I had time. But honestly, this took longer than I expected, and it's almost 10 p.m. and I'm kind of tired today, so I think we'll leave that to next time. But it's good that we got this one done. I'm sure the effects people will appreciate this one, so that's good. So yeah, I think we're gonna call it quits this time, and let's see. Yeah, let's spend a proper day on the speaker stuff when I'm not like half falling asleep. But yeah, this was a fun one. It's not that bad. 200 lines of code to this. It's just I am dreading the upstream bike shedding over this if they even want to let me implement it. But for now, it's going to be in our downstream kernels. Fex can use it. The API is dumb enough that, hopefully that part won't be too controversial. And we'll see. Okay. See you on the next stream.